I will also honor John.
Okay, thank you.
Let me make sure I accomplish one thing.
I will take notes. I think that's not a problem. I doubt we're going to have sufficiently complex discussion. Think we can get any more
Maybe.
people here.
Maybe.
Give it a minute or two. Excuse me, starting with a short session. Okay, so I guess we should get started. This is the Rmcat working group. I'm Colin Perkins. I'll be chairing. The co-chairs are Anna Brunstrom and Martin Stiemeling, neither of whom can be here today, unfortunately. I see we have several remote people. Can you confirm that the audio is working before we go on? Cheching, can you hear us, Bernard?
I have one yes.
One yes. Okay, so I guess that's working.
Yes, I can hear you guys.
Okay, thank you. Yeah, okay, good. All right, so as usual, we begin with the notes well. I'm sure you have seen this before. Please note it, and if you can't read the text, there's a nice big URL which you also can't read because it's cut off by the pop-up which says mirroring the screen, which has the URL for the note well on it. The slides, all the materials are on the data tracker. We have Meet Echo, we have Jabber. Jonathan Lennox has kindly volunteered to monitor the Jabber room and also to be the big red button pusher for Meet Echo. So if there are remote questions, I will let Jonathan press the button to let you in at the appropriate time. We also have a mailing list. Please consider subscribing if you haven't done so already. And I will be taking notes. So our agenda today, we've got this brief introduction and status update. We'll then talk about the eval test draft from Zahed for 10 minutes or so. I suspect it will actually take less than that. Chao-Ching will then talk about the video traffic model draft and the updates on the NADA implementation in, I guess, Firefox. And then Julius will finish by talking about NADA implementation experiences and then an issue with the coupled congestion control draft. Working group status. We've got a bunch of candidate congestion control algorithms and related drafts. Coupled congestion control draft is with the RFC editor, but we'll be talking about it later, and we may have to pull that back briefly. Scream and SPD have been published as RFCs some time ago. NADA, the working group last call, has been completed, and that's waiting for the chairs to do the write-up. And we apologize for the delay, and I will prod Martin to finishing his write-up again. And GCC has gone dormant. The authors have indicated that they're not planning on updating it at this time, but if they change their minds, we will happily be waiting and ready to take the draft back. The requirements draft has been in the RFC editor queue for about the last 4 years and is blocked on cluster 238 along with many other things. So hopefully that will appear relatively soon. The evaluation drafts, the eval test, the eval criteria, and video traffic model drafts, we have had working group last calls on all of those. Eval test and the traffic model we're going to be discussing later today. The eval criteria isn't on the agenda to discuss, but it was updated earlier in this week. I see Jörg is there. Do you want to comment briefly on the status of that draft?
Yeah, you're good. So essentially, we have an update of this one that addresses all comments except for strengthening the security consideration sections. That requires a bit more thinking. That wasn't easy to be done at the quick shot that we gave it. The other requirements seem to be in an okay shape now, so that this could move ahead. We'll hope that we'll be getting the security consideration sections updated also soonish. Okay. An interesting question is on how much you would actually want to say there specifically. I mean, this is about experimentation, and so
my guess is it will probably say that there are no specific security issues with experimenting, but your implementations of it probably need to consider blah blah blah.
Right. So, but we wouldn't want to discuss of what people would need to consider, what they might leak as side channel information from their congestion control mechanisms or their timing of packets and whatnot. This is not of interest, right? In itself, the draft seems to be pretty easy on that.
Yeah, I mean, my guess would be that it probably wants to say that experimentation probably doesn't have any great security issues, but pay attention to the security considerations of the drafts you're implementing when you get to that point.
Okay, that's probably something one can do quickly.
Yes, the eval test draft, I think, got an update to the security considerations in this last version, and you should probably do something very similar to that.
Okay, I'll steal some text from there. That's good.
Okay,
thanks.
Okay, so it sounds like the status of that is that we're looking for an update to revise the security considerations. At that point, we will, unless there are objections, do a brief working group last call to confirm and then move it forward.
Just an correction. I think we were eval test 06. We ran last call on.
Okay. Right. So I got the wrong version of the draft. Yeah. Okay. Fine. Yeah. So eval criteria, we will wait for Jörg to do an update to revise the security considerations and then do a brief working group last call. Right. And we'll discuss the other two in a few minutes. Wireless tests, we have previously decided that this was ready for working group last call. Once the other evaluation drafts are done, I see no reason to change that decision. So hopefully in a few weeks, once we've got the other ones out of the way, we can working group last call that draft. Feedback message was discussed in ABT core, and we'll talk briefly about the hackathon stuff in a second. The congestion control feedback draft, which gives advice for how to use the feedback message draft, has I think currently expired, but we will update that once the feedback message has been completed to reflect the final state of the feedback message. The two interfaces draft, the framework and the codec interactions, I think the current plan is to reconsider those once we've moved the candidates forward to standard track and to leave them at this time. We have a set of milestones. As usual, they are out of date. What I am proposing and what I've discussed briefly with the co-chairs is that the milestone for submitting the requirements and evaluation drafts, which was August 2017, we will move to December 2018, since those are essentially ready to go. So hopefully we will actually then meet that milestone after having moved it forward 18 months. The interactions, this is codec interactions, the framework will push forward a year or so, so they go to after We have hopefully done the congestion control drafts. The evaluation results and the proposal for the standards track congestion control algorithm, we are proposing to push forward to July next year. I suspect that's aspirational and optimistic, but we may as well be aspirational and optimistic, and we can always change it again in the summer meeting if we don't make that. Congestion control to proposed standard, we're suggesting to push it forward a year, and again, it's likely that that will slip, but we may as well be optimistic and try and encourage people to do it. And the other two milestones, publishing draft of techniques to detect instruments or diagnose failing to meet RT schedules. I think no one is quite sure what that is, so we're proposing to remove that milestone at this time. Any comments on these changes?
Mia Kulevin. So those milestones was meant to provide some kind of invent measurement. So if you deploy your congestion control, you want to capture certain metrics to figure out that the loss rate didn't go to like infinity or whatever and report that back. But given there's no work ongoing on this part, I'm okay to remove it.
Yeah, and we have monitoring in with RTCP and all of that. So there is monitoring infrastructure in place already. Yeah. Okay. All right. Last thing I have, there was a small group, so it was Niels and Jonathan and was it Sergio remotely here, looking at implementing the congestion control feedback draft in the hackathon, and I think they made some good progress. We had a discussion of that in AVT Core earlier this week, and I think we resolved most of the issues, and we'll be seeing an update to that draft hopefully within the next week or so. Jonathan, anything to report to this working group?
Jonathan, yeah, I think the one thing that came up in AVT Core where we felt like we needed more feedback from people actually implementing congestion control algorithms is how should the feedback mechanism handle duplicated packets? Because the feedback is indexed by sequence number, so obviously if a packet is duplicated, you can only report on it once. And the question is, what would be the most useful report in that case? Report on the first arrival time, the most recent arrival time? Should we, I don't know, maybe add some additional flag, which would be a format change, saying this, packet got duplicated, something strange happened, or what? I mean, so I feel like we need, what is going to, be the most useful for the congestion algorithms to get the information. So if people who've done congestion algorithms could give feedback on that, would be helpful.
Do I kneel?
You move the mic.
Oh, hang on.
You can kneel if you'd prefer.
That looks better. Go first. I don't know of another congestion control feedback mechanism that reports duplicates at all.
Okay, I mean,
So maybe we don't have to go to that complication of actually bothering with this.
well, we need to specify something.
Yeah.
We report on the
First,
packets.
last.
Packets may be duplicated.
Because you have arrival times, not just arrival times. So which time?
Yeah, you should choose one, is what I'm saying.
Mia Kulevin. So arrival time, I think you should choose the first one because that's when you actually process a packet and then you just throw away the duplicate, right? So that doesn't matter. You also have ECN feedback in there, right? You might want to it can also happen that you get the packet, you send a report back, and then you get the duplicate, right? Then it's already too late. But if you actually happen to receive the duplicates before you send out the report, and one of them had a congestion marking, I think you should report on it because it's still a signal from the network.
Okay, so the suggestion was report the time of the first one, and if you get multiple ones and one is ECN marked, then report the mark. Yeah. Okay.
We'll bring that to AVT Core, but I have no objection to that in principle, and unless anybody else has any comments. Okay. The other reason why this is an issue is not just the network duplicating packets, but because certain implementations of Firefox don't support the RTX payload format, so use packet duplication for handling packet, retransmissions. Which,
Yeah, okay. Chao-Ching, does that seem like it would work for NADA? Okay. Okay, so it sounds
Yeah,
like
sorry for for handling duplicating packets, I second what Mira has suggested.
okay. Thank you. All right. I guess we're done with that in that case. So we will now move on to, I can work this laptop to the next presentation. Which I can. Right, there we go. Which is Zahid. And you'll be pleased to know that these slides are no longer 75 megabytes in size.
Thank you. What have you done with the slides? Yeah.
Just got rid of some non-important bits.
Okay, so this is about a status update of this eval test draft. We went with working last call for 0.06 version, and so we got some comments and reviews. Actually, I'm very pleased to see like a detailed review from the reviewers and comments, and we authors, especially me and Xiaoxing, actually worked through the reviews and comments and updated that one. So next slide. We have a 0.07 version addressing mostly all the comments we got, and thanks for the review. So next one. So let's focus on what we have. I mean, there are typos, there are things that's quite trivial that is come up with the review, thorough review. So I'm just focusing here what's basically changed that I think you guys should be aware of. Obviously, you can do the diff. So the thing here is like, I think one word is missing here. So the thing here, like we had this fixed capacity, path capacity, and then we said like we'll use some other traffic to actually change, like non-responsive UDP traffic to change the path capacity. And then me and Sergey kind of worked through a new formula, which basically is more, I think, more what is supposed to say. We have a table with all the path capacity and path capacity ratio. Now, if we apply the formula, and then you will see like what kind of UDP traffic you will be throwing at. So, anybody has a comment on that? Xiaosheng, you want to say something? We can see you, but you are not talking.
No, I'm good here. I don't know, did I trigger some? Yeah, I don't have comments. Sorry, maybe there was a confusion.
all of a sudden, your video is showing up on the screen, so we assumed maybe you wanted to say something.
Okay. I'll mute that if I'm not talking then. Yeah, I'll mute both the audio and the video. Sorry about it.
That's
Great. So, anybody has any comment? Have you applied this to according to the table and see like, well, this is the right thing? We kind of did, authors. Yeah, I think it's fine then. The next one, we kind of, I don't like it. This is on the 0.6 version, and we kind of missed the expected behavior for two of our use cases. So it was basically kind of hidden into the text, but we didn't really wrote it as a separate section. So that's what we did. So test case 5.7, this is about the short-lived TCP flows. And basically the expected behavior here is like when you have short-lived TCP flows, you actually kind of media bitrate kind of go to the minimums, stays there. When the short-lived flows are gone, it will be like into the steady state, and obviously the what it should show is like it's gone down into the lower minimum bitrate. It doesn't stay there, so it's actually ramp up to the steady state. So that's like the behavior, expected behavior added. On the test case 5.8, that's like pause and resume. This is basically, I think everybody showed the results with the expected behavior. So we just wrote that this is pretty simple. Like when you pause it, then basically rest of the flows should go and grab the bandwidth almost equally. They should converge. And when you again kind of like start your paused media, it should be able to find its way to some convergence where all the three flows are steady state. So I think we had some discussions about 5.7 within among the authors, like what it should do. But for 5.8, it was pretty obvious. We have been showing actual results displaying this kind of behavior, so we are fine. Any comments on that? Anybody? Doesn't like it? No, change it?
It's fine to me.
Yeah. Okay, fine to me as well. Next slide. So security considerations. There it used to say like security issues have not been discussed in this memo. I personally thought that's like very understatement. So we kind of wrote a new security considerations. So what does it say? It says like these condition control, this test case, you're supposed to run simulators or in a controlled environment where you know what's happening. It's basically a lab environment or your simulators. So we don't expect anything that impacts the desired results. So you should which one? Okay, there's something, the copy paste thing, I guess. So I hope it is not the same on what it says. But the idea here is like, well, you should not have some traffic that impacts your results in a controlled environment. And then we also refer to eval criteria. If there is a security consideration there, every condition control will have to write the security consideration. So when you are particularly testing something, you should be considering that. And then we get a suggestion like we should also mention like we should not let the test things leak into the internet, where our condition control algorithm has not been tested or something. Like you should not leak this lab thing into the internet and flood the internet and break the internet. You shouldn't do that. So I think that's a very valid comment. So we just incorporated that one. But this is kind of like, pretty simple security considerations. I don't know like what else need to be covered.
So Gary Fairhurst, did you really have the last sentence as well? I agree with the last sentence's intent. I suggest it should be a separate paragraph when you actually write it, because the congestion control thing's a little bit different. And I think you probably need to be more explicit than avoid leaking, because you just say this isn't to be used in the general internet, or something that's a little bit more concrete, so that somebody who's silly enough to think that that might be the case is very clearly advised not, because hopefully people in this room already know that last sentence. Someone else reading this who isn't familiar with what's going on, who has to be warned that in some way this is an experiment that has to be controlled and used in a controlled environment.
Yeah,
I like the controlled environment text. It appears in many drafts that we write around here.
Okay. If you have suggestions for what that sentence should say, please talk to Zahid.
The more I talk, the more I realize you were going to say that. Yes, I will just look now.
Yeah. So if you have some suggestions, just send it to. And we think we also find a typo, but I don't think like we need to update that one. But this one, if you think like this need to be updated, the last sentence, then we should update it. So that's it. What's next for my question to the working group?
The English is not broken in the draft, it's copy paste.
It's the copy paste thing.
Okay, so what this seems to me is we need a minor update to revise the security considerations, which I'm hoping can happen later today. what I would then propose is that we do a very short working group last call, 1 week or so, to confirm that everyone is happy with it, and then move this forward.
Yeah, and also like I think in the mailing list you guys have seen, like there is a confirmation from the comments, the reviewers, that the current draft actually addresses their concerns. So we're fine from that angle.
Yes.
To be super quick, what was the draft name?
It's draft IETF Rmcat eval test.
Eval
test, yes. And I'm expecting some input from Gori on the last sentence of the draft. Thanks.
Okay, great. Thank you, Sahib. Okay, next up is Cha-Ching. Okay. Is there something on Java?
Sergio said he left his agreement as a reviewer.
Yes, yes. Thank you.
Hello, I just enabled both my video and audio. You guys should be able to hear me.
Yep, we can hear you and we can see you.
Great. Yeah, so I'll give a very brief update on the video traffic model draft. Oh, draft. I don't know why it showed up twice. Next page. Next page, please.
Okay, you've got the second slide up. It takes a little while.
Great, yes. So basically, we have, after the working group last call, sort of within that period, we've gathered a collection of reviews. There were sort of 2 batches. That's why we kind of updated the draft twice. First from 04 to 05 to address a collection of comments both from Colin and from Jeremy Fu. So I'm listing out the main one here is in adding a section of security considerations. By the way, Jay Collin later on in his review also pointed to the missing of that section. And this is the text that we have added to the security considerations. And I thought it would be convenient to post it up here for people to review and provide comments. Do I need to? I can read it out briefly. So basically, we mentioned that it is important to evaluate RTP-based congestion control schemes using realistic traffic patterns so as to ensure stable operations of the network. Therefore, it is recommended that candidate RTP-based congestion control algorithms be tested under using the video traffic models presented in this draft before wide deployment over the internet. So it's sort of more not necessarily like a security consideration for the traffic models that's being presented, but rather more as a recommendation for people to try out their candidate scheme using the more realistic traffic pattern. If there's any other suggestions or comments, I'll be happy to incorporate that as well. And I'll just finish that round of update and fix a couple of other terminology, sort of issues mentioned by Colin, basically avoiding the use of Rmcat right in our draft, as well as fix a couple of issues we run it by the ID NITS checked. So I'll pause here just in case people have comments regarding the text on the security considerations.
Okay, I don't see anyone at the microphone, so I think.
Okay, yeah. Then moving forward, we later also get some additional comments from both Michael and Jake. Those are more sort of editorial in nature. One is in ensuring more consistent use of third-person narrative, and the other one is that Jake pointed out some confusion in our use of the term transient. So we made a pass and tried to make mention of either transient period or transient state throughout several pieces of the draft. Those can be easily identified if you click on the diff view of the draft. Another minor wording changes. I don't think it's worthwhile, those here. Basically, we believe we have addressed all reviewer comments. And by the way, for the more sort of detailed review comments on the mailing list, after we updated the draft, as I remember, I have also provided sort of per point responses to the reviewers. And so we're just posting up it here just to make sure that if there are additional comments or, if the reviewers have follow-up comments so we can accommodate them as well. So to that, I think we're kind of ready. Yeah, basically ready for the working group last call reviewers to check for those comments. And by the way, thanks a lot for all your input and feedback on the draft so far.
Sure. Thank you, Chair Ching, for the updates. From what I can tell, certainly my comments have been addressed. I think, I don't remember, but I think we got confirmation on the list from most people. If there's no comments in the room, what I would suggest is that just after the meeting, I will issue a sort of one-week working group last call to make sure, and then we'll move this forward.
Okay, that sounds great.
Okay, thank you. Next up, I think it's Chair Ching again, talking about the NADA in the Mozilla browser.
Yeah, thank you. So this is an update related to the draft. By the way, maybe a brief mention of the draft update status, as Colin has showed earlier. The NADA draft has completed working group last call, and Martin has provided his Shepherd review sort of comments, and I believe we have actually updated the draft to version 09 to address the individual sort of review comments from Martin. That was a fairly extensive draft. I just want to mention it up here to make sure the status update is sort of in sync with what the chair has in their mind. And so going after that, we have been mostly focusing on the implementation effort in sort of incorporating it inside Mozilla's Firefox browser. And next page.
Yeah, so just confirm that is my understanding of the status as well. So we're just waiting for Martin to confirm.
Okay, that's great.
Okay, next slide is up.
There's a slight delay, by the way. I'm waiting for it to show up on my side. So just a brief review. The way we have made code changes is that most of the changes are in one of the subfolders, and that's one of the modulars within the WebRTC code and in the Firefox code repo. And we've basically took the hack of replacing the default send bandwidth estimation modular, which is in charge of estimating the recommended bandwidth, with an alternative, and that's called NADA bandwidth estimation. And of course, we made changes to a couple of other files to, sort of to enable that change, to enable that switch between the. And also for this version, this is before the hackathon, so we have kept the receiver side of behavior intact, which means that we do not really have a one-way delay measurement as feedback, and we also have not modified the feedback interval provided from the other end. So we sort of have a slightly different version of NADA running in our current implementation. So instead of using one-way delay, relative one-way delay as the congestion signal, as specified in the draft, in this what we consider an intermediate version, we're using the relative RTT as the congestion signal. And also, right now we have not observed many packet losses in our tests. So our code right now has not added those handling for packet losses. So it's kind of a slightly simplified version of the NADA congestion control algorithm. I also want to point out that the default behavior of the RTCP feedback typically swings around the default interval of 1 second. I'm going to show some data on that too. I believe it's sort of plus minus 50%, right, of the target feedback interval. So which means that we're actually operating this congestion control modular kind of at this feedback interval higher than what we have designed it for. So we're also curious to see whether it breaks or whether it still works. And finally, just for convenience, we added a bit of a logging using the existing WebRTC logging framework so that we can pull out the stats to facilitate the graphing. And next page. So these are all the code changes, an overview of the code changes. And next page, please. So the way we run our test, we basically set it up to have one side of the client. So first off, we all these tests, at least one side, the modified version runs on Mac, and then runs on the modified, Firefox nightly build. The collection of changes is summarized below. Basically, for the sender side, we now use the NADA bandwidth estimation modular. We have revised the maximum sending rate to be 4 megabit per second, and also to explicitly configure the default video height to 720p, because in the default Firefox behavior, the video height is at 360p, and that also automatically limits the maximum rate that's allowed, that's specified for sending. And finally, we enable logging states for the outgoing flows in another modular. And there's because we don't require any change from the receiver side, we actually run it over a Chrome, unmodified Chrome behavior for the receiver side. We use app.rc, that's an online, WebRTC tool to enable the call. So we don't do anything other than changing the congestion control modular. So we run 3 sets of tests. The first one is really a sanity test. I have 2 laptops in my home, connected to the same Wi-Fi, and I kind of have fairly unlimited home Wi-Fi. So this is really to measure, whether things work and how fast the rate can ramp. Here I'm showing the 3 set of graphs showing the rate calculated by the NADA congestion control modular. In the top graph is the relative RTT that derived from the RTCP feedback message. Of course, here within a local environment, the base RTT is around 1 millisecond, so that's almost just the actual RTT more or less. And the bottom graph shows the feedback interval of the individual rate, for each RTCP feedback message. As I was mentioning before, basically it swings 50% plus or minus around the 1 second target interval. I kind of looked into the code to confirm that behavior too. This one basically shows that the NADA algorithm, because of the accelerated ramp-up design, it can start from the minimum rate of 200K and ramp up to the maximum 4 meg within 15 seconds or so. So it does ramp up pretty quickly. And then even though this is running within the home, unlimited, but it's Wi-Fi, so occasionally we do see, a spike in the RTT. So NADA kind of reacts to that, but recovers back fairly quickly if we have only 1 or 2 individual RTT spikes because of the minimum filtering we're doing. Next page, please. Next page, please.
Yeah, we did.
Oh, okay. So the delay is appreciable. Yeah. So then we are ramping up the game a little bit. I have a colleague, actually Jen Fu. Jen Tao Fu. He's also one of the co-authors on the draft. He's based in San Jose, California. So we basically carry out the same exercise, except that now the sender is from my side and based in Austin, Texas, and he's from San Jose. So there is a little bit of a remote, that mimics more of a typical remote call. And I was sending out the call from the Cisco office where the receiving end is on home Wi-Fi. Oh, by the way, all these tests are carried over with bidirectional audio video calls. And I'm only reporting on the statistics of the outgoing side. The other side is kind of unmodified behavior. So with this one, what we're seeing is that the base RTT is actually very high. It's around 160 milliseconds. And then also, as we can see that even after you subtract the base, the residual, the relative RTT is fairly spiky and sort of spikes up sometimes quite outrageously. For instance, in the very beginning and towards towards the end of the call. So in reaction to that, the NADA congestion control modular indeed sometimes drops to fairly low rate, and then after the RTT recovers a little bit, ramps up again. So we're no longer seeing a very flat line as in controlled lab tests. We do see these adaptations going back and forth, swinging back and forth. But maybe on the other hand, the good news is that it does not get starved throughout. It does have the capability of ramping back again whenever there is the opportunity, whenever the delay yields a bit. And I see there's a question. Yes, go ahead.
Yeah, Magnus, just why are you sending feedback so seldom? Why is the feedback?
And this is just we have not we want to try first with unmodified receiver behavior. We obviously are interested in testing whether faster feedback helps. In my opinion, it will help because it reduces the feedback loop, right? The delay in the feedback control loop. Yeah, it's just that we want to show kind of an intermediate result.
Jonathan, the impression I get is this is just the regular RTCP feedback. It's the only feedback channel they have at this point because we add the code changes we made to add it were done this past weekend at the hackathon. That should do the real feedback that we want to get.
Okay, I mean, still even with normal, as long as you don't have this, if you scale the 5 seconds and use the other one, it's regular feedbacker should send a little bit often. And if you have the program the bandwidth.
Catch the comment.
I think Magnus was commenting that it should be possible to tune that feedback to go faster, but Jonathan said that nobody understands how to do that.
Okay, is it more that tuning the feedback external to the browser, or is it sort of inside? I did try, I actually hacked into the receiver too. So if you want, we can, kind of hard code.
Yeah. So I mean, yeah, if one would implement according to the specifications and do the scaling, etc., if you use RR and RS bandwidth modifiers in your SDP or similar configuration interface, you should be able to set the RTCP bandwidth so that you get more frequent feedback.
Jonathan Lennox, I would be astonished if libRTC implements RR and RS.
Okay, so it sounds like we possibly have a browser limitation, but it looks to me from a non-NADA expert eye to be behaving sensibly given the rate of feedback it's getting.
Yeah, so yeah, sure. By the way, I want to mention that from our perspective, we are interested in experimenting with other forms of feedback or more frequent feedback. Actually, on our to-do list. It's just that the results we're showing here, we're sort of making staged changes. So we want to, for now, keep the receiver as is, right? Sort of, this way I'll be able to make code changes and call anyone I want without, doing anything special on the other side. But then going forward, we'll be interested in exploring, sort of understand a bit better what new forms of feedback helps and to what extent.
Sure.
And yeah, next page.
Next page is up.
And I'm measuring the latency here.
So it's relaying for Sergio. He says, we realized during the hackathon we were not aware of transport feedback 1 week ago. I mean, we're not aware there was a flavor of transport feedback already implemented. So Jonathan Lennox speaking for myself, Chrome implements the Google Transport CC extensions. I believe Firefox, despite the fact that it has libRTC in there, does not currently implement it, does not currently have that enabled. So in theory, if you were speaking the Transport CC, you could interoperate with an existing Chrome browser. I believe Chrome is using that to feed something presumably equivalent to, though perhaps not exactly the same as GCC. I think GCC was an attempt to document.
Okay.
Yeah.
All right. So we're running a little short of time. So if you could if you could quickly go through the rest of the presentation.
Sure. Yeah. So and then the final set of results is between me and Sergio. So it's a cross-Atlantic call from Austin and to Switzerland. And again, one side is from the office, the other side is from the home, where I'm reporting again the base RTT here, 300 plus millisecond, just to show kind of the challenge. And then, but then I guess this time we got slightly lucky in that most of the time, if we don't see outrageous RTT, NADA actually is able to, sort of reach the 4 megabit per second. By the way, the connectivities, right, even if from the home, etc., are fairly high. But then occasionally we do see those, 1 second, 2 second RTT spikes, and NADA will react back and then try to ramp up again. Yeah, and we're also seeing the corresponding feedback interval sort of reports in the bottom. So sort of similar results. And for us, this is the first set of at least, sort of running in the wild test compared to all previous either control lab tests or simulations. So we're actually happy enough that things didn't really break, or the congestion controller didn't either flood the network or keep starving all the time. But then, of course, we're very much interested in making it more reactive and then trying to see how well it can go. Next page.
You got it.
And as a summary of observations, maybe two things to highlight is that in the let's say in the sort of unlimited scenario, the accelerated ramp up feature in NADA allows us to ramp up to max rate fairly quickly. Sorry, it's not 15 milliseconds, it's a 15 second. That was a typo on my slide. And the send rate briefly due to occasional RTT spikes. And then once we get onto remote connections, the algorithm reacts to RTT spikes, and because of the long feedback delay and the fairly, sort of infrequent interval, it does take, it does have a wider rate dip, but otherwise it sustains maximum streaming rate with, in the presence of random fluctuations. So overall, we actually felt it's quite robust to high RTTs and sort of higher than designed feedback intervals at this point. Next page.
You got it.
I'm waiting on my side.
Yeah, you have the next page up.
Yes, yeah, right. And basically that motivates us in, looking at what to do next. Obviously, this hackathon and feedback messages are something we want to be able to, the result of it, we want to be able to incorporate. And the mention about the existing transport feedback implementation, that's something we'll look into too. But interested in moving it all the way to the implementation as described in the draft, in the sense that we want to use the feedback message as defined, as well as move to all the calculations based on relative one-way delay values. We're also interested in testing the impact of the different feedback intervals, because that intuitively is a very key sort of parameter, and then handling losses, packet losses too, at least adding that statistics and adding our existing algorithm in how we handle it over loss ceilings. And so that's it for the update for this draft.
Okay, thank you, Cha-Ching. It's good to see some implementation experience.
Hi, Julius Flohr. One quick question. Can you make this code available somehow, or is it not done yet?
It's half done. Maybe we will be happy to share a half baked in the sense that feature wise, right? It's not the complete implementation, but yeah, I think if we clean it up a little bit, we'll be happy to share that version.
That would be cool. Thank you.
Yeah.
Okay, great. Thank you very much, Cha-Ching.
Okay. Thank you.
Okay, Julius, you're up.
Thank you. So, for everybody who doesn't know me, I'm Julius Flohr. I'm a PhD student from the University of Duisburg-Essen. Next slide, please. And as you might be aware, we've done an implementation of the NADA congestion control algorithm in the Omnet++ INET discrete event assimilation framework. And we finally managed to update it to the latest version of the draft. And so this talk is supposed to be a short, independent validation of the NS3 model you already have up on GitHub. Next slide, please. And since the last version of the draft has been focused, has had a focus on NADA's competitiveness with loss-based flows. So I'm focusing here on test case 5.6, where we're comparing how NADA behaves with long-lived TCP flows. But in this scenario, we've used SCTP instead of TCP because I don't know the TCP model in Omnet very well. And I know that the SCTP model is quite good because it shares lots of code with the FreeBSD kernel. And so SCTP in this case also used the Neurino congestion control. There's only one thing I'm not quite sure because I don't know whether the X strategy, the SCTP model uses is the same as TCP in NF3 because as you will see in the following graphs, the frequency of the delay spikes you see induced by the loss-based congestion control is higher for my plots. I don't know where this comes from. I guess this has something to do with TCP and NF3. I can just tell you that SCTP X on every other packet. So in this test case, we have a bottleneck with 1 megabit, 16 milliseconds of propagation delay, and a maximum queuing delay of 300 milliseconds. This test case also specifies, I think, 30 milliseconds of jitter, but we don't add that to our model. And also, we've been using a perfect video encoder, which means it immediately always generates the perfect desired sending rate. And also, please note that in this version of our algorithm, there's currently no accelerated ramp-up mode. This means it may take a while for the algorithm to converge to the desired rate. Okay, so on the left side, you see the
Hello, just one question.
Yeah.
When you say perfect, in our test there are two kinds of perfect. One is adjusting the interval. The other is adjusting the number of packets per. So, in which sense is it? What is the flavor you were?
So we're adjusting packet sizes. So we have a fixed FPS, and we're just adjusting the packet sizes.
Thank you.
So on the left side, we see the reference implementation in NF3, and on the right side, the results generated with our implementation. And as you can see, they're basically the same, with the exception that our frequency of the delay spikes is higher, as I mentioned. I don't know why this is, but it still converges to the same operating point. Yeah, next slide, please. This is the same scenario, but with a larger bottleneck of 10 megabit. So again, basically the results are the same. And this is the reasons I only got these two cases, because across the board our curves looks very similar. So it's just not that interesting. Next slide, please. So this is one I guess you haven't seen yet. So this is the new implementation of NADA as it interacts with the synthetic video codec, trace-based codec by Cisco. Here again, the results look good, but for some reason, RTP tends to converge to a lower sending rate. Maybe Sergio or Chao-Ching are able to say something about this. I don't know if their behavior is the same. Yeah, but that's been basically it for this talk. Yeah, again, sorry. The conclusion is we have actually essentially evaluated a large parameter spectrum with both implementations, and the behavior we've seen has been basically the same. And if you're interested in some special simulation scenario, I'd be happy to implement it and push the results to the mailing list.
Hi. So I want to mention for the trace-based results, at least we have also we've also tested in NS3. Maybe we have not shared the slides. I can look back on that information and maybe share it on the mailing list instead, just to, if you want to do that comparison.
Yeah, that would be good. Yeah. Thank you.
Okay. Thank you.
Okay. Great. Thank you very much. It's really nice that we're getting some independent testing of these, and it's also really nice that it's getting very similar results.
Sergio says that Julius.
Yeah, absolutely. Thank you very much. All right. We're a little short of time, so we should move to the next one,
Okay.
which is also Julius.
Yes.
Talking about coupled congestion control.
So we've also been playing with the coupled congestion control flow state exchange. Next slide, please. And so we've implemented version 7 of the document, and we've come across an issue where we find that the document talks about application limited scenarios for the passive version of the algorithm, but not for the active version of the algorithm. I don't know what the reason for this is. So this can lead to issues if we have multiple RTP flows which have different priorities. And if one of these flows is application limited, this can basically lead to situations where other flows don't get more bandwidth, even though they could be getting this because we still have some bandwidth available at a bottleneck. Next slide, please. So as a short reminder of how FSE works in the active cases, so what we have is the congestion control of an RTP flow sends a new desired sending rate to the FSE and computes a delta to what the FSE computed in the last iteration of the algorithm and sums all of these deltas up for periodically. So what we get is an estimate of the bottleneck capacity. And what you can do is you can use that estimate of the bottleneck capacity to share it according to weights among all the flows you have in your flow state, in one flow group. Next slide, please. But the problem here is what happens if you compute a sending rate for a flow which is bigger than what your congestion control can deliver, or which is bigger than what your media source can deliver. Then in this case, in the second step of the algorithm, nothing happens, but you make an error basically for your estimate of the bottleneck, because imagine you compute a share of 2 megabit per flow, but you have an Rmax of 1.5 megabit. And in the next step of the iteration, you report from the congestion control that you would like to send with 1.5 megabit, and actually you decrease your bottleneck capacity of half a megabit. So next slide, please. This leads to situations like this. So this is an example. Here we have two RTP flows with different priorities and a bottleneck capacity of 4 megabit and a maximum sending rate of 1.5 megabit each. And so I would be expecting that RTP in this case, or that both flows in this case, would get 1.5 megabit each. But as you can see, the second flow is somewhere around half of that. Next slide, please. So one way to fix this would be to employ an approach as similar as what you see in the passive FSE, where you compute a total leftover rate. So basically a difference between what your flow can, what your traffic source can generate max and what you wanted to get, and then just add it to the next flow in the same flow group. Next slide, please. Yes, so this is like the same scenario again with that fix. And as you can see, both flows now get the maximum amount of data rate possible. Next slide, please. So yeah, question, is this an issue we should address? The question is, how do we get this Rmax into the flow state exchange? Maybe in the FSE register message. But also we have to distinct cases where we're not limited by what our congestion control could deliver, but maybe what can the media source deliver. So imagine you have a very old webcam which only does like 640 by 480 or so. Yeah, how should we proceed there?
Any comments on this?
Michael Welze. First of all, thanks a lot for playing with this. I mean, quite nice to see. Second, so the reason we didn't have the leftover rate in this version is just, I mean, I was now looking back at the history of the old presentations. We had it in the passive version, then we ended up simplifying it and making it active, and then the whole simplification process, we removed that just to address the feedback from the group. I'd be very happy to have that back in. So I think it is an issue that we should address. I think there is a small issue with the algorithm, but that could be fixed, and it's probably not a big thing. Actually, if you could go back a few slides. Right now, I'm not 100% sure what's wrong here, but something seems wrong because it seems that if there is a leftover rate to be added to the FSER calculation of the very first flow, the very first flow is always going to get 0, right? So something here seems to be in the wrong place.
Oh yeah, that might be. Sorry, yeah.
Yeah. So this is
Yeah.
it seems like a minor thing. I mean, it's definitely doing the right thing in
Yeah.
principle,
Yeah.
right? Just adding that up. It may be that the plus TLO has to go below the if block or something like that.
Yeah.
But I mean, it's just a minor detail, and I think this is easy to fix.
Yeah.
But in principle, I mean, I like this a lot. I think this should happen. I remember that, I believe I remember, I'm not 100% sure, but that maybe a part of the discussions that led us to remove it was also the second question that was on the last slide now regarding the interface.
Yeah.
You know, I think there was a wish to keep the interface simple and not to have so many interactions and things coming to us. I'm not sure. I believe this may have happened. I think FVC register is a good place to have it.
Maybe if it's
Whatever people want,
if it's still too complex, maybe we could just make sure that in the document it says specifically that this might lead to undesired behavior, and that you should implement the passive version of the algorithm if you want to have total control. I don't know.
I mean, I think we don't want complex, but we do want correct. So
Yeah,
if we
so
have to be
I
slightly more complex to be correct. We should be.
I agree. I mean, I never understood why that would be so terribly complex, but I think we were a bit maybe overcautious in you know, trying to keep our complexity out and really simplifying. Yeah, that's my view.
So what I'm hearing is that that this seems like a real issue and we should address it, and the question is just how we go about addressing it. So does that make sense to people? Okay. So I'm seeing a couple of people nodding. Okay, so this draft is with the RFC editor. So at this point, we can either do this in OF48 or we can pull it back to the working group. Sorry?
It's not one, it's cluster 238.
It's not in cluster 238. No. Yes. Yes. My belief is that this is probably too substantive a change to just make an OF48. So if our area director is comfortable with this, what we probably want to do is try and pull this back to the working group, make the change fairly quickly, and then re-last call it and send it back. I don't know if that area director is here. She might be at the back, hiding behind Jonathan.
So I guess this is more than just an oversight, right?
Yeah, it's an oversight, but it is a technical change. I don't know.
I mean, in theory, we could add it and I could approve it, but let me think about it for a second. The other option would be to have a small draft that updates this draft, but that also doesn't seem to be right. So, yeah.
Okay, so it seems like the conclusion is we agree that this change should be made. If you could get together and propose a change, and then we will discuss with the area director and the RFC editor the right way of getting it incorporated. Okay. All right, great. Thank you very much. Is there anything anyone else wishes to bring up before we finish? No? Yes?
I'm trying, Gary Fairhurst, I'm trying to write some security considerations text. I wonder if it perhaps applies to many of the drafts from the working group. So I will send comments specifically on this one, but I think there's a number of security considerations that point to one another, and maybe the chairs or the working group wants to have a quick look at the security considerations across the current set of drafts.
Across the current set of evaluation drafts?
Yeah, maybe some of the other drafts. I will send comments, but I'm just saying that, hey, they might benefit from copying some of this text into other drafts or citing this particular set of security considerations across the drafts.
Sure. Okay.
jump on because I was just wondering if, I feel like the hackathon work was moderately successful, and I was wondering if people were interested in trying this again in Prague.
If there's interest, that sounds like a good thing. Yeah.
Okay.
All right. Great. Thank you very much. In that case, we will see you all in Prague. And if you have a blue sheet, please bring it to the front. Thank you.